Hello everyone, welcome to our channel Coders Arcade. In today's video, I'll be talking about bitwise operators in Python. In my earlier videos, I have explained 6 types of operators in Python. If you haven't watched them, I'm giving the link in the description. In today's video, I will be talking about bitwise operators in Python. So what does bitwise mean? Bitwise means bit by bit calculation on any given integer number. Suppose we have a given integer, we convert it into its binary form and then do operation on it bit by bit. The operation done on each and every bit is known as the bitwise operation, and the operator used in this case is known as the bitwise operator. Now the question arises, how many types of bitwise operators are there? So let me tell you, there are 6 types of bitwise operators in Python. They are bitwise AND, bitwise OR, bitwise XOR, bitwise NOT, bitwise left shift, and the bitwise right shift. So let us take some examples to understand them better. Let us take the first one, the bitwise AND operator. Here you can see I have written A and B. Here A is a variable and B is another variable, and I have written the ampersand symbol, which is actually the bitwise AND operator. So A bitwise AND B, or A and B you can say. Here the logic is the output is 1 when both the input bits are 1, or else it is 0. What it means is, whenever the input bit from A is 1 and the input bit from B is also 1, then only the value or the answer is 1. Second case, when A is 1 and B is 0, the output is 0. In the third case, when the input from A is 0 and the input from B is 1, then also the output is 0. In the fourth case, when both A and B have the same inputs 0 and 0, as you can see here, then the answer is 0. So only in the first case where both the input bits are 1, then the answer is 1. So let us take an example here so that you can understand it better. Here I have taken an example where I have written A, I am taking the value 10, and B I have taken the value of 11. And for 10, this is the binary representation, it is 1010. For 11, this is the binary representation, which is 1011. So according to our example, when we do A and B for 10 and 11, let us go to the earlier example. Here, as you see, when A is 1 and B is 1, then only the output is 1. And in all the other cases, the output is 0. So, coming to our example, in case it is 0 and 1, so the output is 0. Here it is 1 and 1. According to the previous example, when both are 1, then the output is 1. So, in this case, A is 1 and B is also 1. So, the output is also 1. In the last case, as you can see here, 0 and 0 produces 0. So here it is 0 and 0. So the answer is 0. And in the final case, when both the input bits are high, then the answer is 1. So the total answer is 1010, which is the binary form of integer 10. Therefore, A and B, when the value of A and B are 10 and 11, the answer is 10. Therefore, 10 and 11 results in the output to be 10. Let us check it with the help of PyCharm. Here I am taking A is equal to 10 and I am taking B is equal to 11. So here you can see A is 10 and B is 11. And according to our example, 10 and 11 have the binary forms as given, and the result was 1010, which was 10. So here 10 and 11, I will print the binary by using the inbuilt keyword bin. I will print binary of A, then I will run my program, and as you can see here, it will print the binary representation of A or 10, which is 0B1010, and this is the binary representation, and 1010 is the binary form of 10. Again, when I print bin of B and run my program again, it will print the binary representation of 11, which is 0B1011, and this 1011 is the binary form or value of 11. So just to make it easier to understand, I will comment it out, say hash 1010 for 10, and for 11 I will write 1011, so that we can understand it better. I will remove this thing and I will take another variable C is equal to A and B. Here this ampersand is the bitwise AND operator. What it does is it calculates the bitwise AND operation between A and B with this binary values and calculates the result and stores it in the C variable. So I will print C and I will run my program. Here you can see the answer is 10, as we saw in our example. Now you can see here, when we did the AND operation between 10 and 11, we got 10. So according to our PyCharm also, we are getting 10 as the answer. Now here I will print the binary value of C as well. So I will use the bin keyword bin of C, and now I am running it. You can see here is the answer 10, and here is the bin C keyword that we used. So it brought out the binary representation, and this is the 1010 binary value for the integer 10. So this is the bitwise AND operator in Python. Next we will move on to the Bitwise OR operator. Here, as you can see here, I have taken two variables A and B, and I have separated them with the help of this pipe symbol or the Bitwise OR operator. This pipe symbol, as you can see here, is the Bitwise OR operator. So this statement is A or B. Here the output is 1 when any of the bits is 1 or else 0. It means that if any of the input bits from A and B is 1, then the resultant bit is 1, or else in other cases it is 0. I have taken an example 10 and for variable A, and for variable B I have taken 11, and here is the binary representation of both the variables, 1010 for 10 and 1011 for 11. And then here you can see when any of the input bits from A and B is 1, we will be getting 1 as the answer, because the output is 1 when any of the bits is 1 or else it is 0. So 0 and 1 will produce the output 1. 1 and 1 will also produce the result 1, because any of the bits has to be 1. Therefore the answer is 1. In the third case both are 0, so the answer will be 0. In the fourth case as well, the answer will be 1, because 1 and 1 is the input. In case of the AND operator, when we did the AND operation between 10 and 11, we got the result as 10. In case of the OR operator, when we are doing 10 or 11, we are getting the answer as 11. Now let us check it with the help of PyCharm. This was my earlier example where I used A and B as 10 and 11, and then A has the binary representation 1010 and B equal to 11 has the binary representation 1011, and then I took a variable C is equal to A and B, then I printed the result of C, and then I printed the binary of C. This is 10 and this is the binary representation of 10, and this is the binary form of the value 10. Now I will change this AND operator and use the pipe or the bitwise OR operator. So this becomes A or B, and then when I run my program, you can see that the result is 11, and here in this case, and this is the binary representation of 11, and this 1011 is the binary form of 11. So this is the bitwise OR operator. Now let us move on to our next operator, which is the bitwise XOR operator. Here the output is 1 when both the bits are different, or else it is 0. Or you can represent it like this: the output is 1 when there are odd number of 1s, or else it is 0. So what I mean to say is, when both the bits are different, here both the bits are same, it is 1 and 1, so it is 0. In this case it is 1 and 0. See, both the bits are different, therefore the answer is 1. In this case also 0 and 1, it is different, therefore the output is 1. In the fourth one, both the bits are same, therefore the result is 0. Let us understand it with the help of an example. I have taken 5 as a number and 10 as another number. This is the binary form of 5, 0 1 0 1, and this is the binary form of 10, which is 1 0 1 0. So 5 XOR 10, when we do it according to our initial example, 1 0, both the bits are different, therefore the answer is 1. Here also 0 and 1, both the bits are different, therefore the answer is 1. In the third case also 1 0, both the bits are different, therefore the answer is 1. And in the fourth case as well, both the bits are different, 0 and 1, therefore the resultant output is 1. So the final answer is 1111, which is the binary form of the number 15. Therefore 5 XOR 10 is equal to 1111 or 15. Hence 5 cap 10. This cap is the bitwise XOR operator. This cap here you see is actually the symbol for the bitwise XOR operator. It is also known as cap or the bitwise XOR operator. So 5 cap 10 is also known as 5 XOR 10. So let us check this in PyCharm. I have taken A equal to 10 and B equal to 11. Then this was the OR operator where we used the pipe, and then I printed my result and the binary of the result. Now I will change this pipe and I will change it to my cap symbol. This becomes the bitwise XOR operator now. So this statement is C is equal to A XOR B. I have the values 10 and 11. Now when I run my program, you can see in the console the value is 1, because only in the first case the input bits are 0 and 1, they are different. Therefore in this case only we will be getting 1. In all the other cases the input bits are same, 101 101. Therefore in this cases we will be getting 0 0 and 0, and the final one is 1. Therefore we got this 1, 0 B 1, and this 1 is the binary form of 1. So if we take another example, say I will take A equal to 5 and B is equal to 10 and run my program, then you can see, as we saw in my earlier example, I am getting the answer 15. As you can see here, 5 cap 10 is 15, and this is the answer 15, and this is the binary representation of 15, and this is the binary number 1111 for 15. So this is the bitwise XOR operator. Now let us move on to the next operator, which is the bitwise NOT operator or the complement operator. Bitwise NOT is represented by this sign, which is called the tilde. So tilde represents NOT of A or the complement of A. Like whenever we want to do inverse of any bit, then we use the NOT operator. It actually reverses the value. The output is 1 for 0 and 0 for 1. Negation of 0 is equal to 1 and negation of 1 is equal to 0. So let us take an example. Here I have taken 10 is equal to 1010. This is the binary form, and when we do NOT of 10 or complement of 10, we get the exact opposite. As in our example we saw, negation of 0 is 1 and negation of 1 is 0. So for 0 it is 1, 1 is 0, 0 is 1, 1 is 0. So it's exactly the inverse of the number. So we should get for 10, it should be 0101, but when we do it, we get the answer of minus 10 as minus 11. Let us now see why we get this with the help of PyCharm. This was my OR operator. I will delete all this and write a new line. I am taking A is equal to 10, and then I am printing negation of A. I am running my program. You can see in the console the answer is minus 11. Here in this case, minus 10 is equal to minus 11. We should get minus 11, but computer cannot store a negative value inside its memory. Therefore it considers positive value of that particular number. So minus 11 cannot be stored. Therefore computer takes the positive value, that is 11, and stores it in a different manner. Let us now see how it is actually stored. Let us see how minus 10 or negation of 10 is minus 11. For that, what the system or the computer does is, the positive value 11 is taken, and this is the binary representation of 11, and we take the 2's complement. 2's complement is calculated as 1's complement plus 1. So 2's complement of 11. This is the binary representation of 11, and on this we have to do the 1's complement. 1's complement is nothing but exactly opposite. The input bits are reversed. So 1011, when we do the 1's complement on it, we get 0 for 1, again 0 for 1, again 1 for 0, and for 1 it will be 0 again. This is the basic 1's complement of 11. This is the binary representation, this is the 1's complement. Now if we add 1 to it, it becomes the 2's complement. The value of this 2's complement is 0101. This is the 2's complement, and when you see this result binary form 0101, it is actually equivalent to this negation of 10 which we did earlier, 0101. So therefore we can understand that computer stores this negative value as a positive value by taking the 2's complement. Therefore we are getting negation of 10 is equal to minus 11, which is 0101, because to get the answer, computer takes positive value of 11 and then takes 2's complement, hence we get the result as 0101, which is negation of 10. Complement of 10 or negation of 10 is 0101. 2's complement of 11 is also 0101, hence negation of 10 is equal to minus 11. If we have to take a basic formula for this, it is negation of 10 is equal to minus of n minus 1. Suppose the value of n is 10, then negation of 10 is minus 10 minus 1, which is equal to minus 11. This is the basic way to understand this. Now let us go to the bitwise shift operators. First of all, we will look into the bitwise right shift operator. Here in the right shift operator, I have taken a variable a is equal to 10. This is the 8-bit representation of the integer 10. As you can see here, there are 8 bits, 1, 2, 3, 4, 5, 6, 7 and 8, and this 1010 is the exact number, and just because we need to represent it in the 8-bit form, therefore 4 zeros are added. Now when we shift a to the right side by 2 steps, this is the symbol. What it does is it shifts the bits 2 steps to the right. Now when 10 is shifted 2 bits to the right side, as you can see here, the last 2 bits will be discarded and all this other 6 bits will be shifted to the right. As you can see by the picture here, all this have been shifted. Just because 2 spaces are left behind, there are 2 bits added, which are 2 zeros. These are the 2 added bits here. So when these 2 are discarded and these 2 zeros are added, we get a new number. So when 10 is right shifted by 2 bits, we get the answer as 10 right shifted by 2 bits is equal to 2. Here you can see this is the binary 8-bit representation of 2. This is the final answer when 10 is right shifted 2 bits. Let us check this in PyCharm. I will remove all this and then I will write a is equal to 10. Then I will take another variable. I will first print binary of a, and then as you can see here, I am getting the binary representation of a, and then I am taking another variable b is equal to a right shifted, this is the symbol for bitwise right shift, by 2 steps. This is the step which we need to give. It can be any number. I have taken 2 here. Then I will print b, and then again I will print the binary form of b, bin of b. Now when I am running my program, you can see that this was the binary of a, and when I am shifting a by 2 bits, then I am getting the answer as 2. As you can see in the example, when 10 is shifted 2 bits, then the answer is 2. So I have taken the variable b, and then when 10 is shifted by 2 bits, then I am getting the answer 2. And when I am printing the binary of b, I am getting this binary representation, and this is the binary form 0, 1, 1. Now let us come to the bitwise left shift. Bitwise left shift is the same as the bitwise right shift. In this case, only difference is that it will be shifted 2 bits or any number of bits to the left hand side. Here I have taken a number 138 and I have taken the binary representation of this number 138, and then I am shifting it by 2 bits to the left. As you can see here, this 6 bits will be shifted to the right and the front 2 bits will be discarded, and this 2 bits are added to the right hand side. So this is 138, and when 138 is shifted 2 bits to the left hand side, the 6 bits are coming here and 2 bits are added. So this is the answer. Hence 138 left shifted by 2 steps is equal to 552. Let us check it with the help of an example. I am taking a equal to 138, then I am changing this shift operator. I am doing it left shift. I am printing the result and I am running my program. You can see here, this is the binary representation of 138, and as you can see here, this is the 8-bit binary representation of 138, and I am performing the left shift operation and I am getting the result of 552, and this is the binary representation of 552, and Finally, I'm getting the result. So this is the bitwise left shift operator. So this is all about this video, guys. Thanks for watching. Hope you like the video, and if you like it, then tell us in the comment section below. If you have any doubts, then post them in the comment section. I will definitely try to clear those doubts. Also, like, share and subscribe to our channel Coders Arcade and press the bell icon so that you will get a notification when we post a new video. Thank you. Happy learning.